I mentioned in the last video that 99% of the aromatic compounds that you'll see in a chemistry or organic chemistry class is either going to be benzene or a molecule derived from benzene. Or a molecule derived from benzene. So what I want to do in this video is just familiarize you with some of these molecules and how to name them, so you know what you're looking at, or I guess so you can name what you're looking at. So you've seen this multiple times. Benzene just looks like this. It's a 6-carbon ring with 3 double bonds. These 3 double bonds like that, and it's not its only configuration. Sometimes it's shown to be in resonance with this form right here. So the double bonds all flip around the circle like that. Or sometimes it's simply drawn like this. And I talked about this in the last video, just to show that really neither of these configurations is exactly right, that these pi electrons are just circular, they're just moving around the entire ring. So and sometimes you'll just have the hexagon with a circle on the inside to show that the pi electrons just floating around the entire ring. Now, if I were to add something to the benzene ring, it's pretty straightforward to name it. So say I have this molecule right here. This molecule right here. So let's say I have that. That's benzene. But let's say this carbon over here, it has 1, 2, 3 bonds. If I didn't draw anything else, you just assume that there's also a hydrogen here. But maybe there's no hydrogen there. Maybe, let me do this in a different color. Maybe you have a chlorine there. Well, this is just this is just chlorobenzene. Chlorobenzene. If that was a bromine, it would be bromobenzene. So pretty straightforward. If, let me draw it, let me change it a little bit. Let's say you had a chloro there, and let's say you had a, oh, I don't know, let's say you had a bromo over here. Let's say you have a bromo over there. Draw the bromo. So you could just start numbering. You could actually start numbering in either place. Let's start with the bromine. It's alphabetically in front. So this would be 1 bromo, 1 bromo, 2 chloro, 2 chlorobenzene. Pretty straightforward. Now it gets a little bit more involved. The IUPAC, which we know is kind of the group that named most things, they tend to, everything else we've seen so far, they came up with a separate naming mechanism from the common names. But benzene, it's so ingrained in the organic chemistry community that all of the benzene or benzene derivative molecules, they just kind of said, well, you know what, we're just going to use the names that everyone uses. So here's a couple of common benzene derivatives. So if you have this molecule right here, if you have this molecule right here, I'll actually draw the pi electrons as a circle. Actually, I'll draw it with the double bonds. So let's say you have this molecule right here, and over here you have an OH. You have an OH right there. This is called a phenol. This is called a phenol. So it's not called benzene anymore. And if you had a molecule that looked like this, if you had a molecule that looked like this, so just like a phenol, so it's essentially, it is a phenol. It is a phenol, but let's say you have a bromine right there. What you do is you start numbering at the group that's making this a phenol. So you start numbering there, 1, and then you get to the 2. So this is 2 bromo. This is 2 bromo phenol. 2 bromo phenol. And unfortunately, this is one of those things that you just kind of have to memorize, that a phenol is really just a benzene ring with an OH group. Another one that is probably a good idea to memorize, I mean, at least for me in organic chemistry, the most confusing thing is when someone says the name of a molecule that it sounds like they expect you to understand, but you don't understand it. So it's, I guess, a good idea to understand as many names as possible. So if you just have a benzene ring, and then you just have a methyl group, you just have a methyl group attached to that benzene ring. This is called toluene. Toluene. And once again, if you had a, let's say you had a fluorine right over there, this would be 1, 2, 3 fluorotoluene. I always have trouble saying that. Because 1, 2, 3. You start at the group that's kind of making this the toluene. And so let me make it a little bit clearer. So this would be 3 fluorotoluene. This would all be in one word. I just wrote it up here to save some space. Now, a couple of other ones that you'll see, and once again, as you know, if you watched many Khan Academy videos, I hate memorizing things, but these are just names, and these aren't systematically derived. The chemistry community just uses them because that's the way they've heard them. So it is one of those things you kind of have to memorize. So if you have a benzene ring, if you have a benzene ring, where the functional group that's kind of defining the benzene ring it's essentially becoming an amine. We haven't actually covered videos on amines yet, and I'll do that in a future video. But it's essentially it's replaced one of the hydrogens in ammonia. Ammonia is let me draw ammonia. Ammonia has 3 hydrogens and one lone pair. Here we've replaced one of the hydrogens. Actually, there's 2 hydrogens here. We've replaced one of the hydrogens with a benzene ring. This type of thing, you call it aniline. Aniline. Aniline right there. And the same idea. If I put a fluoro here, this would be 2-fluoroaniline. So you use whatever the base molecule is, and then you just name it really the way we've named a lot of things before. And I'll just introduce you to 2 more, just so that you have them under your belt, so that you will have seen them before if anyone introduces them to you. And they're really introducing groups that we'll study in more detail in the future. But if you have a benzene ring, once again, so we have a benzene ring. And then you have a carboxyl group. And we'll talk more about carboxyl groups in the future. But it creates carboxylic acid. This thing right here, this hydrogen can actually be released quite easily. And we'll talk about that in the future. This right here is called benzoic acid. Benzoic acid. And this name, actually, there is a little bit more logic to this. You have the benz part for the benzene. So let me make this in different colors. The benzene part, that gives us the benz right there. And then in general, whenever you have a carboxyl group like this, it becomes a carboxylic acid. And you tend to add the oic acid to the end. So this actually has some logical naming to it. Now the last one I'll introduce you to is very similar to this. Instead of having an OH right here, we just have a hydrogen, and it would be an aldehyde. So let me draw that. And you could almost imagine what that's going to be called. It's benzaldehyde. So let me draw it. So you have your benzene ring. You have your benzene ring. And then instead of this carboxyl group, you have an aldehyde group. An aldehyde group, you have your carbon. There's implicitly a carbon here. Let me make that just in case it's the first time you're seeing it. You have a carbon there. Instead of an OH group, you have just a hydrogen. And so once again, you have a benzene. So it actually makes sense to put the benz over there. And then you have the aldehyde group. And then you have an aldehyde group right over here. So this is called a benzaldehyde, or this molecule is called benzaldehyde. Benzaldehyde. And we'll study amines and aldehydes and carboxylic acids in much more detail in future videos and actually see reactions that involve them. But I just wanted to expose you to this. And when you see these things, so when you see these kinds of names, you don't become intimidated.